Hello friends, today we are going to start with the Bezout's theorem. Okay, this statement is that if D is a GCD or the HCF or the greatest common divisor of two positive numbers A and B, then there exists integers x and y such that D can be written as a linear combination of x and y. Okay, and this d is the least positive value of ax plus by, and we are going to prove it. Okay, so let's start with the initials or the essentials of this theorem before we prove this theorem. Okay, so let's begin. This is the part 1. So this is the part 1 of this tutorial or video, and here we'll prove another theorem that again we'll use in part 2 to prove the Bezout's theorem. Okay, so that I've named it as the base theorem. Okay, so let's begin. See, if a positive integer is divided by b, again a positive integer, and the quotient is q and the remainder is r, then the GCD of a and b equals the GCD of b and r. Okay, and this we'll prove it. So let's do it. See, we assume the GCD of a and b to be d and the GCD of b and r to be e. Okay, now GCD of a and b equal to d implies that D must divide A and D must divide B. Now D must divide A and D must divide B gives D must divide A minus QB. Okay, because D divides A and D divides B. So D divides any sum or difference of A and B, even if B is multiplied by Q. Okay. So what is A minus QB? A minus QB is nothing but R. So D divides R. So D divides R, D divides B. So D is a common divisor of B and R. Okay. And what is the GCD of B and R? GCD of B and R is E. Okay. So D divides E. Okay. This is our equation 1. So next part. Now B of R, GCD of B of R is E. We have assumed it here. See here, B of R is E. Now E divides B and E divides R. Okay, so E will divide BQ plus R, or E divides B and E divides R implies E divides BQ and E divides R, and adding those two we get E divides BQ plus R. And what is BQ plus R? BQ plus R is A. See, BQ plus R is A. Okay, so E divides A. So E is a common divisor of A and B. See, E divides A, so E is a common divisor of A and B. Therefore, E divides D. Now, what is D? D was the common divisor of the GCD of A and B, and E divides E is a common divisor of A and B, and the highest common divisor of A and B, that is the GCD of A and B, is D. So E must divide D. So we have this equation 2. Okay. So D divides E was the equation 1. E divides D was the equation 2. From 1 and 2 we have D equals E, and hence we have proved our fundamental concept for further proving the uh, Bezout's theorem. So let's end it here and we'll meet in the next part. Okay, thank you very much.